Hi, this is Ms. Claywell with 4.5 Factoring Higher Order. So the front page of our notes is a graphic organizer that's going to help us remember all the different factoring techniques that we've learned this unit that will help us when we factor higher order on the back page. So first thing we do is we look for a greatest common factor. So anytime we're asked to factor, we look and see what all terms have in common. So once we've looked for the greatest common factor, we look for the number of terms that we have. We're going to go ahead and fill out the 4 terms first, because that's the one that we learned. We learned this, and this was lesson 4.1, and it's called grouping, where we look at see what the first 2 terms have in common and the second 2 terms have in common. So these, I can pull out an x squared, and I have an x squared plus 1. These I can pull out a 5. And x squared plus 1, and then I see I have my matching terms. I pull out my matching, then I get my leftovers. So this is grouping. We learned this in 4.1, if that's helpful for you to process that this was 4.1. Here I can pull out a 3n squared. Here I can pull out a 4, a 2n plus 1. Here's matching. And here's my leftovers. So this was 4.1 when we had 4 terms. And then we jumped to 4.2, which is when we had 4 terms. So this is all 4.2 if you want to mark that somewhere. This first example is difference of squares. This is difference of cubes. This is difference, or not difference, but sum. So when I look at this first example here, to me this looks like something cubed minus something cubed, because I have an x to the third. 64 times, or is the cube root. If I take the cube root of 64, I get 4. The cube root of 1 is 1. So this is my a and b, and I'm going to use my difference of cubes. This looks like the equation number 2 in the list above. So I'm going to do a minus b, a plus a times b plus b squared. When I rewrite that, this is what it will look like. The second one, I see that 25 is a perfect square and that 36 is an x squared. Or 36 is a perfect square, so this is 6 and 5x. This is something squared minus something squared. The way this is set up makes it look like it's going to be like formula number 1 on this sheet. So I do a minus b, a plus b, where I identified my a and b. So this was all 4.2. 4.3, wherever it's helpful for you to write it, this is an ACB tree. So I'm actually going to do the bottom one first. I'm going to start with seeing if there's a GCF. I see I can pull a 3 out of this. A times C is 20. My B is -9, -5, and -4. So this page here is just a reminder. So I'm going to rewrite -9 as -4 and -5. So -9x is the same as -4x minus 5x. I'm going to see if I can pull out the first two. If I can pull the second two, I'm going to pull out a -2 and get a 2x plus 1. I'm going to pull out a 5 and get a 2x minus 1. I made a mistake over here. This should be a minus. Then I get my matching of 2x minus 1, my leftovers of 5x minus 2, and I keep my 3 with me. So an ACB tree allows us to write 3 terms as 4 terms and then do our grouping. When same idea here, I don't see a GCF, a times 3 is -42, but adds to my b of -9, so I have -7. Sorry, I made a mistake here, right? My b here is a positive, is a -1, so I have -7 and 6. I can use shortcut when a is equal to 1. Where my magic numbers of -7, -6 are just the other parts of the factor. So if a is equal to 1, if I start with like a 1x squared, I can use my shortcut. Okay, so this is all for the front page. Go ahead and jump to the back page. So now we're going to practice factoring something that's higher order. To factor something that is higher order, that means that the highest degree is 4 or above. So step 1 I want to do is put the quadratic in standard form. Look for a GCF. Then I want to factor completely. And then it wants us to name what method we use, so we're going to be doing that with these. If I look at number 1, I don't see GCF. It's in standard form. I see 3 terms. Look at my front page. When I see 3 terms, I use an ACB tree. So A times C is -4. My B is -3, so I'm going to do -4 and +1. My A is not equal to a 1x squared, so I cannot use my shortcut. This is a -4x squared plus 1x squared. Notice how I have to rewrite, if I'm breaking up a -3x squared, I have to rewrite it with an x squared as my middle terms. Okay, so I broke it up. Now I can do finish ACB tree, which is grouping. Thank you very much. Here's my matching. Here's my leftover. Okay, so the first thing I used here was ACB tree. That got me to this point. I notice here that this is difference of squares. This is an x and a 2. So go from this row to this row. I use difference of squares. At the end. Okay, let's try number 2. Put it in standard form, so let's do step 1. I do not see a GCF. I see 3 terms when I have 3 terms, I do a CB tree. A times C is 24, but adds to a B of negative 14, negative 12, and negative 2. My A is not 1x squared, so I need to rewrite it. So I'm breaking up my negative 4x squared. So far I've done ACB tree is this first method. I'm going to finish my ACB tree. I'm going to pull out a negative 2 from this one. I have matching and leftovers again. This is something squared minus something squared, just like I have on the other side, and x and 2. So x minus 2, x plus 2. And then I have to keep my 3x squared minus 2 term. So this last method I used here was difference of squares again. Okay. We're going to do problem 4 first. I'm going to pull out, I see a GCF of a 4. So that method was a GCF. Now this looks like I can do something squared minus something squared. Square root of 4 is 16. Square root of x squared is a 4x squared. So I have 4x squared minus 1, 4x squared plus 1. I still have my 4 from the beginning. So this is difference of squares. I have my 4. I see this looks like it's difference of squares again, a 1 and a 2x. So I have 4, 2x minus 1, 2x plus 1, 4x squared plus 1. And this is difference of squares again as my method. So sometimes we use multiple methods. This is not difference of squares for number 4. Okay, last one is we're trying example 3. I see that they all have a negative 3 in common. So I'd pull out a GCF. And more than a GCF, I can pull out a negative 3m. Okay, and now I can do an ACB tree. What adds to 3 but multiplies to 4 is going to be 3 and 1. And I can rewrite this as a 3m to the third plus a 1m to the third. And I can pull out an m to the third. From here I can pull out a 1. So my matching is m to the third plus 3, m to the third plus 1. Okay, then I did ACB tree. What I see here is something third plus something to the third, an m and a 1. So I'm going to do sum of cubes. I want you guys to pause the screen and do that part on your own with an A and a B. And then I end up with this sums of cubes that I used at the end. Okay, happy to help with any questions that you guys have in class.